Hello, this is Sadbir. The topic of our discussion in this video is how to find relative extrema with second derivative. We will start by looking at the graph of this function. Here in the graph, I have a couple of local max and there have one local min. So what we can notice that when we have the local maxima, the graph of the function has a bending downward. And what we can conclude that the function is will be concave downward when at a critical value if the function has a local maxima. So now from the previous video we have learned that when the function is a concave downward, the second derivative of that function is negative. And similarly, if the function has a local minima at a point, the bending of the curve is upward. Therefore, the second derivative is positive at a critical value where the function have local minima. And same conclusion can be drawn here. So if the second derivative of the function is a negative, we have a local max. If the second derivative is positive, we have local min. But what happens if the second derivative of the function is 0? This we can see in this graph. Here the second derivative of the function is 0 and you see that we still have the local minimum. And here the second derivative of the function is 0, but we do not have any extrema, neither local max or local min. So it means this, if the second derivative of the function is 0, we cannot draw any conclusion. So no conclusion can be drawn if the second derivative of the function is 0. So I can summarize this whole discussion about the local maxima and local minima with the second derivative by using the second derivative. So this is our second derivative test. So in order to implement the second derivative, in step number 1, we will calculate the first derivative of the function and that set that is equal to 0, and that will give you the critical values. So now in step number 2, basically we will have the critical value when we say solve the first derivative is equal to 0. Let's suppose you have critical value x is equal to c. So in step number 3, this time we will use the second derivative instead of the first derivative. So the first thing we will do in the step number 3, we will calculate the second derivative of the function. And then we will plug the critical value in the second derivative of the function. If the sign is a positive, we will say this is a local min. If the sign of the second derivative is a negative, we say this is a local max. And if the second derivative is 0, it means it's a signless, then no conclusion of this test can be drawn, and we have to use the first derivative test in order to uh, find whether the function has a local max and local min at that critical value of the function. So the step 1 and step 2 are same. We will find the derivative of the function, and in step number 2 we will find the critical value. And step number 3, instead of using the line test, we will use the second derivative test to draw the conclusion whether the function has a local maxima or the function has a local minimum. Let's understand this concept with an example. So I have this example, which is a polynomial 2x cubed minus 3x squared plus 7. So again, I will start with step number 1. In step number 1, I will calculate the first derivative of the function f prime of x, which will be 6x squared minus 6x. And I will simplify a little bit. I can pull out 6x. So this is the x minus 1. In step number 2, I will calculate the critical value of this function by setting the first derivative is equal to 0. This will gives me x is equal to 0 and 1. These are my critical value. critical values. So in step number 3, instead of using the line test, I will calculate the second derivative of the function first. The second derivative of the function is 12x minus 6, because here is the first derivative. The one more derivative is 12x minus 6. And then I will plug my critical value into the second derivative. So if I do so, I will get minus 6 here, which is a negative sign. And if I plug 1, I will get a positive 6, which is a positive sign. So this implies x is equal to 0 is a local max, and x is equal to 1 is a local min. So positive will give me the min, and the negative will give me the max. So this is our local max, and this is our local min, all these critical value. Here I have one practice problem for you. So please pause the video 1 or 2 minutes, and once you have your answer, you can submit your answer in the link above. Here one more problem, which is a bit more challenging than the problem we have before. In these problems, we have a function which is the quotient of x square and x square minus 1. So once we have the quotient function, it is always a challenging to calculate the derivative of this function. So in step number 1, we will begin calculating the derivative of this function by using the quotient rule. So f prime of x. So if you want to practice the quotient rules, please go back and watch the videos on the quotient rule. So this is how I calculate the derivative of the quotient function. I will write down the quotient, the derivative of the top function on the top and the bottom function on the bottom, the derivative of x minus 1 on the bottom. And then I read that, this chanting, which say low d high, high d low. So low multiply to high and high multiply to low. And I will write down here. So if I multiply low to high, which is x minus 1 is multiplying to 2x, and minus high to low, x square is multiplying to 1 is just x square. And then low, which is a x minus 1, the square of this function. And I will erase this piece. So once we have the high d low, low d high, I will just simplify the derivative of the function by, so the top, by simplifying the top is a 2x square minus 2x minus x square, and it is whole is a divide by x minus 1, the square of that, which gives me minus x square and minus 2x divided by x minus 1, the square of that. So that is the derivative of the function. And in step number 2, I will calculate the critical value of the function by setting the top and bottom is equal to 0. If x square minus 2x is equal to 0. And also I will set the bottom is equal to 0, which is x minus 1, the square is equal to 0. This gives me x is equal to 0, and also gives me x is equal to 2. This gives me x is equal to 1. So you can notice that x is equal to 1 is not in the domain of the function. So this critical value is not in the domain of the function. So I will reject that critical value. There will be no local max or local min if a value does not basically belong to the domain of the function. So these are our 2 critical values, and we will use basically the second derivative test on these critical value to find whether it has a local max and local min. So what we'll do, I will go into the second slide, and I will calculate the second derivative of this function, which is x square minus 2x. So in step number 3, my first order derivative is x square minus 2x divided by x minus 1, the square of that. I will calculate one more order derivative of this function. So derivative at the top is 2x minus 2. Derivative at the bottom is 2x minus 1. And we'll do this chanting low d high, high d low. And this time I simplify this function. So if I multiply low to high, it's going to be x minus 1, the square of that. And this I can pull out 2 also. So it's 2x minus 1. And this is a 2 time x minus 1 time. I can pull out x from top is going to be x minus 2. And x minus 1 to the power 4. Let's see if we can simplify this derivatives. You see that x minus 1 and x minus 1 is a common factor here. So I will pull out x minus 1. So x minus 1. And then the left is basically x minus 1, the square of that. I can also pull out 2. So that's gone. So this is going to be left with minus x square minus minus plus 2x. And whole entire thing is divided by x minus 1 to the power of 4. This will cancel the 1 power here. So you have a 2. And this is going to be x square minus 2x plus 1 minus x square plus 2x, which is x square is cancelled with this is cancelled with that, and I will left with x minus 1 to the power 3. So my second derivative of this function is 2 divided by x minus 1 to the power 3. So now test the critical value. I have two critical value, 0 and 2. So if I plug that critical value 0, this gives me a negative sign. So this is gonna gives me a negative sign. And if I plug the other critical value, which is a 2, it's gonna gives me a positive sign. So x is equal to 0 is a local max, and x is equal to 2 is a local min of the function. Here is the overview of this this problem. So as we seen, then x is equal to 0 is a local max and x is equal to is a local min. Here I also have the first derivative test so that you can also compare your second derivative test with your first derivative. So you see that I calculate the first order derivative of the function, and this was my first order derivative after the simplification. That's my second order derivative of the function. First order derivative gives me these critical value, but x is equal to 1 is not the domain. So we will push that value out. And here you will see the first derivative test, and here is the second derivative test is applied. And you can also compare that they have the same conclusion that 0 is the local max and 2 is the local min, as we have in the previous previous calculation. So here I have one more problem, which is a bit more challenging to calculate the second order derivative of this function and also the first order. So I will begin this in step number 1 to calculating the derivative, first order derivative of this function. So f prime of x will be using a product rule. So please watch the video on the product rule if you need more assistance in using how to calculate the derivative of the function by using the product rule. So this is a square, and we will pull out the common factor, which is x to the power 3 and x minus 1 to the power 2. So that is the first order derivative. It's going to be a 4x minus 1, and this is going to be a 3x. If I simplify this function, this is going to gives me 7x minus 4, if I simplify this one. So now in the step number 2, the critical value of the function, x is equal to 0. If I set the derivative is equal to 0, x is equal to 1, and s is equal to 4 over 7. These are the critical value. Step number 3 is going to be a bit more challenging, but it's just a polynomial function. If you use the product rule 3 times, you will calculate the second derivative of this function. Since I already calculated the second derivative, so this is 6x square, x minus 1, 7x square minus 8x plus 2. I calculated the second derivative and then simplify, but you don't have to simplify the second order derivative. So then I will test these critical values. I will plug these critical value. X is equal to 0, x is equal to 4, 7, and x is equal to 1 into the second derivative. So if I plug x is equal to 0, as I can see, that is simply 0. That gives me 0.24, which is a positive number, and this gives me a 0. So you notice the second derivative test is only giving you a conclusion here, where the function will be local, is giving you the local min, but the test is inconclusive here. So there is no conclusion can be drawn what is happening at x is equal to 0 and x is equal to 1. So this test will give you no conclusion what is happening at x is equal to 0 and x is equal to 1. So we have to use the first order derivative test. So we will repeat this step number 3 here, because no conclusion was drawn by the second derivative test for x is equal to 0 and x is equal to 1. So what we will do the line test, 0, 1, and then you have here 4 over 7. So if you use the line test, you have pick a point here, which you're gonna use on the first derivative of the function, and you're gonna pick a point here, and point here, and plug into the first derivative of the function. So here is the first derivative is a positive. Here you will get a negative. Here you get a positive, and here you get a positive. So our conclusion from the first derivative is this is a local function is increasing and decreasing. So this is a local max. This is a local min, which is the same as we drawn the conclusion from the previous. This is a local min. And this one is neither. So no max and no min at this value, which is x is equal to 1. So this is our first order derivative test. Derivative test. So if your second order derivative test fail, you have to use the first order derivative test in order to make the conclusion about the local max or local min. Here is an overview of this problem again. So we calculate the first order derivative and the second order derivative. First order derivative give us the critical value 0, 4 over 7 and 1. And when we plug these critical values into the line test, these conclusions we can draw which one is a local max, which is a local min. But when we do in second derivative test, no conclusion can be drawn on 0 and 1. So the test is inconclusive. So second order derivative test is not effective when this second order is 0 at that critical value. So here is also the graph of the function where you can see that where local max and min occur, and where it does not occur, but you have to use the first order derivative test. Here I have another clicker question and the quiz problem for you. So stop the video for a minute and two, and put your response in the link above. So what are the conclusion of this lesson is that the second derivative test does not require any line or to find or a table to find the local extreme of the function. So this is the one benefit of the second order derivative test, is that your calculations sort of better reduce sometime if it's easier to find the second order derivative. The second conclusion is that if the first order and second order derivative is zero, the second order derivative test is inconclusive. So first order derivative test can only be used. In this case, f may or may not have local extrema at x is equal to c. So you cannot draw any conclusion from the second derivative test. When you have the choice, use the second derivative test when finding the f double prime is not too complicated, because it will require less calculations using the second order derivative test if your function is a polynomial function, because polynomial function, their second order derivative is easier to calculate. And the first order derivatives require a table and number line for the values of x. So this is different than the second order derivative test. Okay, this is the end of this video. And if you like this video, hit the subscribe button, also the bell button, so that you can watch my next video. I will see you in the next video. Bye for now.